Hello, and thank you for joining me. You're here with Data Science Teacher Brandyn, and we're going to learn how to build the perceptron in with Tensorflow and with the sequential model. So in our data set today, we have 40 features. They're all numeric features, so all the pre-processing and everything is done. And we have in our training set, we have 10,500. So we're going to go tf.chars to sequential. We're going to be assigning this to our model perceptron. And so inside of a list, we're going to be going tf.chars.layers.dense and then 40. So you don't have to do this often. Especially when I'm doing this a lot, I'll import the layers library from tf chars import layers. And then just use the layers library. It is very often done in this sensor here, so I'm not going to put that, but it's very often done in tf.chars.layersDense. Here I'm going to do the number of neurons that we're going to have. I do have 40 in my data, 40 columns in my data set, 40 features, and so I could do a bigger one, just kind of sticking with as simple as possible. So essentially one linear regression for each feature. Okay, and we're going to do activation. You can use any activation here, truly, but in the classic function, the sigmoid is what we started with, and that was from 1948. There are lots of limitations to sigmoid, especially with the simplest type of perceptron. There are some places for it. It doesn't work good overall. There's my favorite one is the ALU, the exponential linear unit, many different ones. So here I'm just taking the shape. So I'm taking the second position, remember 0, 1 Python indexing. And so we're taking 40 from right here, and then I'm just doing a 1 as the output layer right here. So this is just doing, so I'm giving this a list too, and just notice the comma here, and then the second item in the list is my next layer in my sequential model. And then we're going to do model.compile. And compile, I'm going to say the loss is the mean squared error regression problem today. And our regression problem is also why we only have one, because every neuron, really what it is just a linear regression with with an output. So we just don't really have to do anything really at all. Just give it to given neuron in its raw form, and we get a linear regression right here. And so we're just going to measure MAE right here, or optimizer, again from tf.chars.optimizers RMS properties is root mean squared property is what that stands for. Helps me remember knowing what that actually stands for. And I'm going to set the learning rate to 0.1. It's so simple, I actually really had to turn up the learning rate a lot more than I normally would. And I'm also going to look at the root mean squared error here. Just looking at the model here, as simple as it can be, we have our dense layer right here with 40 neurons. This is our input, taking this in with 40 features, and then 40 neurons here in our first dense layer, and then our output layer right here. So input, hidden layer, and then output. As simple as it can be. Okay. And so here we have our model.fit, doing X train, Y train, validation split, and then 200 epochs. I wanted to see how good I could get it. I'm going to assign this to history. This is not necessary, but it is really valuable to really look at the history. It's something that I don't feel comfortable that I even understand what the model is doing until I view this, specifically the history. So here we plot it, and we can see our epoch by epoch and kind of watch a train if we have nothing better to do, or we can come back when it's done. And what I'm doing here is I'm just making a subplot, making a figure and an axis. I'm not giving it anything but the fixed size, so it's going to be just a one spot in a figure, and I'm going to make it 10 by 4, so width of 10, height of 4. I'm going to put the best thing to do, the easiest way is to put the history object into a pandas data frame, because they're dictionaries with a list of what happened during the time. And so we go history.history and then index into the loss out of the dictionary of history, we get the list of the history, essentially. Okay. And so here we're going to go plot.x, and we're putting it into this x-axis right here. We did this so that we can do then the validation loss, and then do the x equals x, ax, as well here, our axis object that we created from the subplots in Matplotlib. And then plt.title, font size, font weight, bold, make it a little bit different. I'm just doing a line break here right in front of this to give it a little bit more space, just kind of particular makes it look a little bit nicer. And then I'm also doing plt.legend, and I'm setting loss and then bow loss as well, so we can see, so we know which is which. Okay, so, and then we can see it learned pretty fast. It wasn't able to improve, and it started really overfitting quite early, around 50. I trained it to see what would happen as long as it would go. But we can see really that there's a limit in the perceptron. It really was not able to. It's not really able to do anything more than learn kind of simpler uh, patterns and stuff. So we don't have layer upon layer upon layer that can learn these complex patterns on patterns on patterns. But it is still very interesting how it works. It's a really good starting place to learn about deep learning. So thank you for joining me today, and I will see you next time.